section 7.7, our objective here is to write a quadratic equation or function given its roots or the graph. So in the first part today, we're going to look at, given the roots of a quadratic equation, find its equation. Well, basically what we do is we work backwards. So remember, when we solve a quadratic equation, we work until we get the variable equal to the root, and so we work until we get something like that. Well, now what we want to do is we want to work backwards. So where did that come from? So if I add 4 to both sides, I get x plus 4 equals 0, and I get x plus 1 equals 0 here if I add 1 to both sides. Okay, and then if I take those two factors and multiply them together, I get x squared plus 1x plus 4x plus 4 times 1 equals 0. Okay? And so the question is, how is this related to the roots? Well, if I wrote it like this, okay, we would see that this number, which is really a 4, is the same thing as the two roots multiplied together. So negative 4 times negative 1 gives us a positive 4, which is exactly what this comes out to be. Okay? And the middle term, this one, is really the opposite of the sum of the roots, because the roots are negative 1 and negative 4. So if I add those, I get negative 5. But it's the opposite of negative 5, which is a positive 5. So I get x squared plus 5x plus 4 equals 0. That is the equation whose roots are negative 4 and negative 1. So in general, if we have root 1 and root 2, then that came from x equals root 1 and x equals root 2, which means that that's x minus root 1 equals 0, and x minus root 2 equals 0. Okay? And so the equation is going to be x squared minus root 1 plus root 2 times x plus root 1 times root 2 equals 0. Okay? And so that is the general, but very often there's also a constant or a coefficient that we need to find that belongs in front there, right? So let's look at example 2. Okay? In example 2, my roots are 3 plus or minus I over 2. Now remember, that's really 3 plus I over 2 and 3 minus I over 2. Okay, so remember, that's really two separate numbers, right? So using this above formula, this represents the sum of the roots, and this represents the product of the roots. Okay? So first thing we want to do is find the sum. Okay? So to find the sum of the roots, we have 3 plus I over 2 plus 3 minus I over 2, which gives us 3 plus I plus 3 minus I all over 2. And so that gives us 6 over 2, or 3. So this is the sum of the roots. Okay? So that's going to be this part, the middle term of the coefficient of the middle term of the equation. Then the other thing I need is the product of the roots. So that's going to be 3 plus I over 2 times 3 minus I over 2, which is going to be 3 times 3 is 9 minus 3I plus 3I minus I squared all over 4. These add up to 0. So I get 9 minus a negative 1 over 4. Or I get 9 plus 1 over 4, 10 over 4, which is 5 over 2. Okay? This then is the product of the roots. Okay? And we know that it's going to be a times x squared minus the sum of the roots, x, plus the product of the roots equals 0. Okay? And so it's going to be x squared minus, and the sum of the roots was 3, so x squared minus 3x, plus the product of the roots, which is this one. Okay, now that is the equation, but we have this fraction here. So to get rid of that fraction, I'm going to multiply the whole equation by 2. So I get 2x squared minus 6x plus 5 equals 0. Because if I multiply that times 2, I just get 0. So you can see my a value in this case was 2. So when we get a fraction here, we clear that fraction, and that gives us our a value. If we don't get a fraction as a constant, as in the first example, where is that? Right here. Then we assume that a was 1 in that case, because that's all the information that we have. Right, so let's do one more example like that. All right, let's do, if my roots are 1/2 and negative 5/2, right? So first step is to find the sum. So 1/2 plus negative 5/2 is negative 4/2, or negative 2. So that's the sum of the roots. Step number 2, find the product. So 1/2 times negative 5/2 is negative 5/4. All right? So that's the product. Now I go to my general form, a times x squared minus the sum of the roots, which is negative 2 times x, plus the product of the roots equals 0. Okay? And in this case, a has to be 4, because we need to clear this fraction. Okay, so we get 4x squared plus 8x minus 5 equals 0. So this is the equation whose roots are 1/2 and negative 5/2. All right, so part 2. Now we want to find a quadratic function given its graph or information about the graph. Okay, so A, find a quadratic function with minimum value -1, whose graph has x-intercepts of 1 and 3. Okay, so first thing I would do is I would plot the information that I know. So I know that the x-intercepts are 1 and 3, and I know that it has a minimum value at -1. Oops, I put this in the wrong place. Okay, this is my x-axis, this is my y. Okay, 1, 2, 3. Okay, now remember the axis of symmetry always goes through the x value of the vertex. And so this goes through at 2. So the x value of the vertex is 2. And remember the minimum or maximum value is the y value of the vertex. So we know the vertex then is at 2, -1. Okay, so we know that. Right now, using what we know, the x-intercepts are really just roots. Okay, so we know a times x squared minus the sum of the roots. So the sum is 1 plus 3 plus the product of the roots. 1 times 3 is 3. Okay, but the question is, what is the a value here? Okay, now we have more information, so we need to be able to find the a value. So what we do is we know that we have a point that works on the parabola, which is the vertex. And so this is my x value, this is my y value. So what I do is I set this equal to y. And I plug in a value that I know works for x and y. So 2 squared minus 4 times 2 plus 3 has to equal -1. And now notice that I only have one unknown in this equation, and I can solve for that unknown. So I have 4 minus 8 plus 3. So it's -4 plus 3 is -1. So it's -1, a equals 1. So a has to equal -1. So I have -1 times x squared minus 4x plus 3 equals 0. So it's -x squared plus 4x minus 3 equals 0. Whoops, I'm sorry, I made a mistake. I dropped a negative right here. So a is actually just a +1. Let's go back and fix this. So again, just being human, I dropped a negative. And so our final answer, a is actually just 1. And notice that I knew right away I had made it a mistake because I know this parabola opens this way. And so it has to be a positive A because if it opened the other way, it would open down. So again, just knowing something about what it's supposed to look like helps you catch mistakes once in a while. All right, so let's look at one more. We have a max value of 4 and x-intercepts of -5 and -1. So again, the first thing I do, and remember again, these are roots. So first of all, I graph it because when I can see it, I understand it better, okay? Well, and because it has a max value, that tells me it's going to open down. Okay? And my x-intercepts are at -5 and -1. So here's -1, 2, 3, 4, 5. Here's -5. All right? And I know the axis of symmetry is exactly halfway between those. So this is the axis of symmetry. The max value is 4. So they intersect right here, so that's my vertex. So where the max value and the axis of symmetry intercept, that is your vertex. So that's 1, 2, 3. So this is -3, +4. And this opens down. So I know that my A value should be a negative number. So we go to our general equation. So x squared minus the sum. So the sum of the roots is a -6 plus the product. The product of the roots is a +5 equals 0. Okay, so it gives me A times x squared plus 6x plus 5 equals 0. Okay, now set it equal to y. And plug in the x and the y that you know work, which is the vertex. So in the vertex, x is -3 and y is 4. So plug that in. So we have -3 squared plus 6 times -3 plus 5 equals 4. Now we can solve for A. So we get 9 minus 18 plus 5 equals 4. So we get 14 minus 18 equals 4. So we get -4A equals 4. So A equals -1. And that looks like it should be right because A is negative, which means it's going to open down. Now come back here and plug in your A. So -1 times x squared plus 6x plus 5 equals 0. Alright, so this is the equation of the function. And actually, I should write it in function notation, so it does say it is a function, because it asks us to find the function. And let me go back to the previous one. So as a function, this one would be written as f of x equals x squared minus 4x plus 3. That would actually be your final answer on that one.